So continuation of paper 2, May-June 2020. Question 23. A narrow beam of a white light passes through a prism and it is dispersed into a spectrum. Which row is correct? The dispersion: violet, indigo, blue, green, yellow, orange, and red. Here, Vibgyor. So violet is having the highest frequency and red is having the shortest frequency. And the refractive index is directly proportional to frequency. The one which is having a higher frequency, greater refractive index, so it will bend the most. But in this option, we have only yellow, blue, yellow, and red. So blue, yellow, and red. So blue will bend the most, and the red will bend the least. And change in speed of blue is more than change in speed for red. In air, they all travel with the same speed, but in a glass, their speeds vary. Question 24. An intruder alarm sensor detects that the person is warmer than his surrounding. Which type of radiation does the sensor detect? Heat radiation. So the heat radiations are IR or infrared. Question 25. Sound travels through air as a series of compression and rarefaction. Which statement correctly compare a compression with a rarefaction? So in a compression, the particles are closer, and a rarefaction, the particles are away. So if particles are very close to each other, so volume will be less. If volume is the relation between volume and density, they are inversely proportional. If volume is less, so density will be higher. So in a compression, the density is higher than compared to rarefaction. Or pressure is also higher. Not about the wavelength, because it's a sound wave, so it has nothing to do with wavelength here. The wavelength is not affected by compression and rarefaction. Number of compression and rarefaction, like if more compression and rarefaction, like if the same question was there, they said the number of the compression and rarefaction in the same region increases. So if number of compression and rarefaction in the region increase, it means that the wavelength decrease and the frequency increases. If the number of compression rarefaction change, then only the wavelength change, but not about individual rarefaction or compression. It does not have any relation with the wavelength. Question 26. So in question 26, 4 nails are there, A, B, C, and D. Are tested to find which makes the strongest permanent magnet. One of the nail is placed against a bar magnet, and the number of the paper clips which the nail support are recorded. So 3 nails are there. Sorry, 3 paper clips are there. The magnet is then removed, and the number of the paper clips remain attached to the nail is recorded. Each nail is tested individually. Which nail becomes the strongest permanent magnet? In strongest, to be a strongest permanent magnet, once there is no magnet, then still it is able to attract greater number of nails. That will be the strongest permanent magnet. So when you check, option C shows a small change as compared to option D. So C is the right answer. Question 27. Look, in question 26, what we want, the question is which nail become a strongest permanent magnet. To be a strongest permanent magnet means it should have a greater strength or greater magnetic field. So if I remove the bar magnet, so this nail is acting like a magnet. And when you check nail C, it is attracting, when it is, there is no bar magnet, it is attracting 3 paper clips. Whereas another nail, it was only attracting two paper clips when there is no magnet. So which nail is a stronger magnet? The one which can attract greater number of paper clip, that is a stronger magnet. That's why option C is the right one. Why it was attracting, why D was attracting more pins in the beginning? Because there was a magnet also nearby, that is why it was attracting more pins. But once we remove the magnet, the number of the pins attracted decreases too much. It means that this is not a stronger magnet. C is a stronger magnet. Question 27. The circuit shows one method of magnetizing a steel bar. How can a circuit be altered so that it can be used to demagnetize? So for demagnetize, what we should use? So if you want to demagnetize, we need an AC supply, because DC supply cannot demagnetize, and we should gradually remove the magnet out or gradually change the voltage so it will be demagnetized. Method of demagnetization, you can heat it, hammer it, or by, why we reduce the voltage, what is the purpose? So that it, all parts will not experience the same strength of the external magnetic field, so which increases the chance. So all parts will not experience the same magnetic field, so it increases the chance to make the domains random. That's why we should gradually either take the magnet out or gradually reduce the voltage to demagnetize. A student used the circuit shown to determine the resistance of two identical resistors. The voltmeter reading across, this is a total voltage reading. What is the resistance of each resistor? Because that this is giving the total voltage and total current. So resistance is voltage divided by current. You will get the total resistance. And they mention these are identical resistance. So total resistance will be equal to R1 plus R2. And they are identical, so their resistance each will be X. So this will be X, this will be X. So we can say the total resistance will be 2X, or X is equals to R divided by 2. So combined resistance is, when you work out the combined resistance, that is 2.2 divided by 0.25, that's 8.8. 8.8 ohm is the combined resistance, and that is divided by 2. So 4.4 is the right answer. Question 29. An electric fire is connected to 240 volt supply. The energy transferred, so power is given actually 1 kilowatt, means 1000 watts. How much charge passes through a fire in 1 hour? In this question, you have to use two formulas. One is relating the power with energy, and the second one relating a voltage and charge. The formula which relate the power and energy, power is equals to energy divided by time. Whenever you are using these formulas, the time should be in hours. Sorry, when you are using this formula, the time should be in second, not hours. No, the SI unit is second. Yeah, it should be in second. By mistake, I was reading the question, so I said hour. So power is given 1000. Energy is there. We don't know. And the time is T, which is 1 hour. So I have to convert into second. So 1 hour, 60 minutes. And then multiply by 60. So this whole is multiplied. You'll get the energy. And then voltage is energy divided by charge. So charge is equals to energy divided by voltage. So this is 6 exponent 4. What is the answer for energy? 3600 multiplied by 1000. What was the answer for energy? 3.6 exponent 6. And then energy, which is 3.6 into 10 to the power 6 divided by voltage, which is 240, you will get the total charge. So C is the right answer for this. Question 30. The diagram shows an incomplete circuit. The temperature and the light temperature and the light level around the circuit remain unchanged. So there is no change in temperature or the light. The electrical component are connected in turn across P and Q. The cell is reversed and four electrical components are connected again in turn across P and Q. Which component there is a significant change in the magnitude of the current? There will be a significant change in the magnitude of current because one way the diode will allow, but when we reverse the current, when we reverse the terminal of the battery, the diode will not allow, so there will be a significant change when there is a diode in the circuit. Question 31. In the circuit shown, ammeter 1 and ammeter 2 are given. Switch S is closed. Which row is correct? If you want to solve electricity question, you can solve in a simple, you can use the numbers to solve these questions, or You can use your understanding. Example, I'm using a number just to explain the idea. Example, if this was a 10-volt cell, okay, the 10-volt supply was there, and this is say 50 ohm resistor, and this one is also 50 ohm resistor. But as you can see, when the switch is open, the only resistance which is effective is the 50 ohm. So total circuit resistance is 50, and what is the total current? We know V is equals to IR. So I is equals to V divided by R. V is the total voltage 10 and R is the resistance. So it will be 10 by 50 or 1 by 5, which is equals to zero point 0.2 amps. So zero point 0.2 amps will be here in ammeter 1, and same zero point 0.2 amps will flow through ammeter 2. But now what happened if I close this switch? Now the effective resistance, what will be the effective resistance of the circuit? As they are in parallel, so what happened to effective resistance? It will be product divided by sum. So 50 multiplied by 50 divided by 50 plus 50. 5 multiplied by 5, 25. So 2500 divided by 100. So this will come out 25. So effective resistance of a circuit will be 25. So V is equals to IR. The voltage does not change. So voltage is still 10 and the resistance is 25. So 10 divided by 25. So 2 and 5, or it will become 0 0.4. So the total current in the circuit will turn 0 0.4, and same 0 0.4 will flow through ammeter 1. This will divide in the branch and 0 0.4 will return. So the question is, if we close the switch, so combined resistance of the circuit will decrease, and as the combined resistance, you know V is equals to IR, voltage is constant. So relation between voltage, current and resistance, they are inversely proportional if voltage is kept constant. So if a combined resistance decrease, the current in the circuit will increase. And ammeter 1 and ammeter 2 both are reading the total current. That is why B is the right answer. The reason why I use the values just to explain the idea. But you can use your understanding that when two resistors are in parallel, the combined resistance decreases, so the total current increases. Which symbol represent the OR gate? The meaning of a voltage is how much energy the one charge carry. Like if there is a charge, when it is moving in the circuit, how much energy this charge carry, that is called voltage. And the number of the charges which are moving in the circuit in 1 second, that is called current. Why A1 and A2 both will change? Because A1 and A2 both are recording the total current. The total current enter, which divide between the two resistor, and then the total current will return. So what happened right now when we connect them in parallel? So the combined resistance will be less. If the combined resistance decrease, so the current which is coming out from the battery will increase compared to the first value. Now there is more current in the circuit. That is why the reading of ammeter 1 and ammeter 2 will increase. Circuit symbol for OR gate. This one is a OR gate. This one is NOR gate. This one is AND gate. And the other one is NAND gate. You have the formula V is equals to IR. You cannot say current voltage directly or inversely unless one is kept constant. Like if resistance is constant, if resistance does not change, we say voltage and current are directly proportional. If current is kept constant, we say voltage and resistance are directly proportional. If voltage is kept constant, we say current and resistance are inversely proportional. So out of these three, one of the values should be constant to find the relation between the other two. So as you can see this circuit, what is kept constant? The voltage is kept constant, because both cases, when the switch is open and the switch is closed, I am using the same voltage supply. So if voltage is kept constant, the current and resistance are inversely proportional. So the circuit which is having a low resistance will have a high current. That's why the readings will increase. Question 33. Input 1, both inputs are 1 and the output is 0. Which one is the right answer? Which combination of logic gates give this result? This is AND gate by multiplication, and not is inverter. Inverter multi or is addition, and multiply and inverter, and not inverter and then multiply and then invert again. So when you check if this is 1 1, what will be the output for the NAND gate? The first part, this will be 1 1 is 1 and then passes through inverter. This part inverter is there. So what it will do, it will invert, multiply and invert. So this will be 0 and 0 passes through inverter, it will make it 1. So it cannot be A. 1 1, this 1 passes through inverter, it will make it 0. And 0 plus 1, so output will be 1. So again this cannot be. When you check C, 1 1 passes through AND, it will be 1, then passes through inverter, it will make it 0. And here 1, it will make 0, and 0 multiplied by 1, it is 0, but passes through inverter, it will make it 1. So C is the right answer. The diagram shows a wire between the poles of a magnet. The wire is perpendicular to the page. The wire is moved and the current is induced out of the paper. In which direction the wire moves? When the current produced due to change in the magnetic field, you will use right hand rule. When current produced due to change in magnetic field. Your first finger, the index finger, should represent the direction of current, magnetic field. Magnetic south. Your second finger will show the direction of induced current. And your thumb will represent the motion or the movement of the wire. So apply not the grip rule, right hand rule. There is a Fleming's right hand rule, and there is why we are not using a left hand rule, because left hand rule is used to find force on the wire which is already carrying a current. When the current produced because of the movement of wire, it's a right hand rule. When we want to find a force on the wire which is already carrying a current, we'll use left hand. There are 3 rules in detail I discuss. I will share after the lecture. I will share that video also with you related to the 3 rules. There is a right hand grip rule which is used to find the direction of a magnetic field. There is a right hand rule which is used to find the direction of a current produced due to the induced magnetic field. And there is a Fleming's left hand rule which is used to find the force on the wire which is carrying a current. So in this example, the wire is not carrying a current, the wire is moving and the current is produced. So whenever the motion or movement of a wire produces a current, we use the right hand rule. If wire was already carrying a current and experience the force, then we use the left hand rule. So in this question, when you apply the rule, your first finger, your index finger should point downward. Your first finger, right, using a right hand, your first finger should point downward. Your second finger, because they mentioned the current produced is out of the paper. So if the current produced is out of the paper, so your second finger should point out of the paper or towards yourself. It should point towards you. Your first finger should point downward, right hand. Using a right hand, your first finger should point downward. Your second finger should point towards you because they mentioned it is out of the paper, so it should point towards you. Where your thumb will point, that is the direction in which the wire is moved. So when you find the direction in which the object, this wire will move, the force that will come out on the left hand side. So this wire is moving from right to left. Is it clear to everyone? The first finger, your index finger should point towards south. Why they mention induce upward out of the paper? Just to clear the idea that it is coming towards you. That's why they mention, if you look, this is when you are looking from the top. But if you look this wire sideways, if you look the wire sideways, then the current produces upward. But if you are looking from the top, it appears that it is coming towards you. That is the reason why they mention induce upward or out of the paper. So first finger should point towards south and your second finger should point out towards yourself. And using a right hand, when you apply the rule, you will find that your thumb is pointing on the left hand side. So this wire is moved actually from right to left or towards left hand side. Question 35. 100% efficient transformer convert 240 volts input to 12 volt output. The output power of a transformer can be maximum as 20 watts. The output of a the output is connected to 2.3 ampere bulbs.